Hello everyone who are watching this video. My name is Marilyn Viner and today we are going to learn about force in 15 minutes. Do you ever heard about force before? Actually, most of our daily activities involve force. A force can change the state of motion of an object. Let's focus in the first picture. The first picture shows that a hand is holding a pen to write on a paper. That means you have applied force to change the direction of a pen when writing. Now proceed to the second picture. As you can see in the picture, a man is holding a trolley. Imagine that you are holding a trolley to find your basic needs in the supermarket. When you push the trolley, you had applied force to move the trolley forward. Then, when you pull the trolley, you had applied force to stop and move the trolley backward. That means you apply force to stop and move the trolley when shopping in the supermarket. In the third picture, you can see that there is a hand pull a handle of a drawer toward. That means you apply force when pulling a handle of a drawer toward you. The red arrow shows you the direction of the applied force that you exert upon the drawer. For your information, pull is a force which you exert to move an object towards you. On the other hand, if it moves away, it is a push. These are the examples of daily activities that involve force. I believe that you have done these daily activities before, right? Force is under subtopic 2.6 for Form 4 Physics KSSM syllabus. At the end of this presentation, you will be able to define force as the rate of change of momentum. So our two key points here are force and rate of change of momentum. In the study of force, you need to know what is F, M, and A refers to. I want to repeat again what is F, M, and A refers to. Do you want to know the answer? Let's move on to the next slide. F is referring to force, M is referring to mass, and A is referring to acceleration. From this picture, you could see that a man is pushing and pulling a table. So, there is a force acting between the man and the table. Force is a push or pull upon an object, resulting from the object's interaction with another object. Whenever there is an interaction between two objects, there is a force upon each of the objects. Force only exists as a result of an interaction. Force has both magnitude and direction, making it a vector quantity. It is measured in SI unit of Newton, which is represented by N. Based on the picture, an example of object with mass is our body. It is because our body is another word someone can use to describe an object with mass, which containing an amount of matter. Mass is a fundamental property of all matter. What is the meaning of fundamental property? Fundamental property is a property that cannot be defined in simpler terms other than to explain how it is measured. Mass is a scalar quantity which has magnitude and no direction. SI unit for mass is kilogram, which is represented by kg. acceleration is the rate of change of velocity of an object with respect to time. To cause an object to change velocity, we need to apply a force. Acceleration is produced when a force acts on a mass. Let's go through into the picture. The factors that cause the acceleration to occur are mass and force. In this case, the mass of the car is constant. For the first situation, small force equal to small acceleration. When a small amount of force applied to the car will accelerate slowly. Then, for the second situation, double the force equal to double the acceleration. When a large amount of force applied to the car will accelerate faster. Acceleration is the rate of change of velocity, and it is vector quantity that has both magnitude and direction. SI unit for acceleration is meter per second squared. So, I have explained briefly an idea of what is force, mass and acceleration are. Then, what is the relationship between force, mass and acceleration? First, relationship between acceleration A and force F. Based on the acceleration force graph below, acceleration is located at y-axis, while force is located at x-axis. And the blue line have shown that acceleration increases continuously when the force increases. It can be said that acceleration is directly proportional to the applied force when mass is constant. It is important when you study the relationship between acceleration and force. You must make sure that mass is constant because mass will affect. So, if you want to know the relationship between acceleration and force, definitely the mass must be constant. What is the meaning of directly proportional? By referring to the graph, the larger the applied force, the higher the acceleration. That's the meaning of directly proportional. Then, this is the symbol for the relationship between acceleration and force, which is A directly proportional to F. By only referring to that symbol, you will get an idea about the relationship between force and acceleration, which is the larger the applied force, the higher the acceleration. Next is about the relationship between acceleration A and mass m. So, what is the relationship between acceleration and mass? Acceleration is inversely proportional to the mass of an object when force is constant. In the study of relationship between acceleration and mass, you must make sure that force is constant because force will affect. Different with the study of relationship between acceleration and force before, the mass must be constant. What is the meaning of inversely proportional? Let's see the acceleration mass graph below. Based on the graph, if the mass increases, the acceleration will be lower and going downward, which means that it is inversely proportional. In the other words, the lower the mass, the higher the acceleration. Then, the expression for relationship between acceleration and mass is represented by this symbol, which is A inversely proportional to m. By referring to the symbol itself, the lower the mass, the higher the acceleration. Now, let's see the second graph, which is acceleration mass of reciprocal graph. There is difference between the two graphs, which is mass and 1 over mass. If I change mass into 1 over mass, remember that when it is 1 over mass, the graph will become directly proportional, as shown in acceleration mass of reciprocal graph. So technically, you will have two graphs of mass. One is acceleration mass graph and one is acceleration mass of reciprocal graph. Remember that acceleration mass graph is inversely proportional. Then if I change mass into reciprocal, which is 1 over mass, the graph will become directly proportional. These are the simple connections between acceleration, force, and mass. From the first box, acceleration is directly proportional to the applied force. Then, from the second box, acceleration is inversely proportional to mass. By combining the two relationships, you will be able to obtain the relationship between acceleration, force, and mass, which showing that acceleration is directly proportional to the applied force and inversely proportional to mass of an object. Therefore, force is directly proportional to mass and acceleration. Then, we will go through into the study of relationship between force F, mass m, and acceleration a. From previous slide, you already know that force is directly proportional to mass and acceleration. As I explained at the beginning of our lesson earlier, acceleration is the rate of change of velocity. This is the formula for acceleration, which is final velocity v minus initial velocity u over time t. When you substitute that formula into A, it will become m in bracket v minus u over t. Bring in m into the bracket, then it will become mv minus mu over t, which is the rate of change of momentum. So, force is directly proportional to the rate of change of momentum, and this is the expression for Newton's second law of motion. Newton's second law of motion. F equal to ma is the formula that you will use later on in the calculation. Newton's second law of motion states that the rate of change of momentum is directly proportional to the force and acts in the direction of the applied force. What is the meaning of that statement? The simple meaning of that statement is if you apply a force, of course, that object will accelerate and move faster. This is the formula that we are going to use in the calculations of Newton's second law of motion. Force is equal to mass times acceleration. Remember that SI unit for force is in Newton, mass is in kilogram, and acceleration must be in meter per second square. In calculation of acceleration, if the unit that were given in centimeter per second square, you need to change it into meter per second square. Important, when you calculate for force, the unit is in Newton. You need to make sure that the unit for acceleration is in meter per second square and mass is in kilogram. Let's summarize. First, the relationship between acceleration and force. Acceleration is directly proportional to force. From the relationship, the larger the applied force, the higher the acceleration. Second, the relationship between acceleration and mass. Acceleration is inversely proportional to mass. That means the lower the mass, the higher the acceleration. Then, relationship between force, mass, and acceleration. Force is directly proportional to mass and acceleration. From this expression, we obtain an expression of Newton's second law of motion, which is Rate of change of momentum is directly proportional to the force and acts in the direction of the force. Last but not least, the formula that you need to apply in the calculation of Newton's second law of motion is F equal to ma. Now, let's see if you can answer one simple question based on what we have learned before. So here is the question to test your understanding. What does Newton's second law of motion state? I hope that you will be able to answer this simple question to achieve the learning outcome in this lesson, which is define force as the rate of change of momentum. That's all from me. Thank you.